Hello, this is Dr. Cole Woolley, and this lesson is called GCMS, Strengths and Weaknesses. This is all about how the GCMS can help me separate and differentiate Oman frankincense from Somalia frankincense. And this is the story. If we look at the GCMS instrument, it's made of two parts. The GC, which is separating the molecules, and the MS, which is the mass spectrometer that identifies and provides a name for each of the molecules and provides the abundance of the molecules, all put together in a GCMS report. In this case, I looked at the essential oil of Oman frankincense and Somalia frankincense. 88 samples from Oman, 39 samples from Somalia. And I did see that from the GCMS, the alpha pinene level was significantly different. It was higher in the Oman frankincense, 79%, versus the Somalia frankincense, only 48%. However, from my experience of distilling frankincense essential oil, I knew that fresh oleogum resin, less than 3 months old, had a very high level of alpha pinene, while old oleogum resin had a low alpha pinene level. So all by itself, this GCMS information really didn't tell me anything. This could be fresh Oman frankincense and old Somalia frankincense. I also looked at the refractive index, which is another test, and the specific gravity, which is another test, and I could see no difference. However, by smelling the essential oil, I could tell that the Oman frankincense, which had a turpentine, mint, lemony aroma, was significantly and slightly different than the Somalia frankincense, which had a turpentine, pine, lemon aroma. The aromas were different, so there must be some component difference in the essential oils. I just had to figure it out. So when I looked and compared the GCMS, the total ion chromatograms, the Sacra and the Carteret frankincense were about the same. All the components were basically the same. Well, that really puzzled me. There must be a difference, but I couldn't see a significant difference. Now let's review the strengths of the GCMS. The GC portion is great at separating hundreds of molecules that are found in each essential oil. The GCMS, the mass spectrum portion, the MS portion, is very good at identifying and naming the separated molecules in the essential oil. Now the GCMS altogether helps to characterize components that are found in essential oils. It gives me as an analytical chemist lots of data to work with. It's a very versatile instrument for me as an analytical chemist to be able to look at the quality of essential oil. But all by itself, it can't do everything. The GCMS is used in the research and quality labs of the best essential oil companies. And I can even use the mass spectrum to be able to look at certain fragments to be able to find them in the GCMS total ion chromatogram. Now let's look back at this data. I looked at some data in the Oman region for different frankincense. I knew from being in the open market that there was a higher price on a frankincense from the Hasik region and a lower price for the frankincense resins from the Mugsail region. These are the two columns that I've set up here. So I analyzed essential oils from these different regions, and this is what I found. The Mugsail frankincense had a higher percent of alpha pinene. Okay, we talked about that before. This could be because it's fresher, but they were significantly different for another reason. For instance, the Hasik frankincense had a higher percent of myrcene and, most importantly, limonene. That's where the lemony aroma comes from. This is why Hasik frankincense from Oman is highly prized by the Sultan of Oman and all the princes and rich people from the Arab countries. They come to Oman usually in June and July of each year and buy up tons of this frankincense to burn in their homes and palaces. Hasek is by far the most prized frankincense from Oman. So what I proved here was, even though the refractive index were the same and the specific gravity was the same, there was a significant aroma difference between these two frankincense from Oman from regions that are only about 50 miles away. Now, these are really chemotypes. They're not different species. They're just grown in different regions, different microclimates, and they are chemotypes. Well, there are weaknesses to the GCMS as well. The GCMS cannot separate all the essential oil components. Sometimes two of them line up together. The GCMS can also not identify every single essential oil component. Some of them are not listed in the reference library. The GCMS cannot determine if an essential oil is natural and pure. It also cannot differentiate between natural and synthetic components. The GCMS cannot do this. It requires other instrumentation to be able to identify if an essential oil is natural and pure. So I needed to use something else besides GCMS to be able to differentiate between Oman frankincense and Somalia frankincense. So what I found was that I could not tell any difference between Boswellia sacra from Oman and Boswellia carteri from Somalia. The refractive index was similar. The specific gravity was similar. There was no statistical difference. And even the GC was too similar. So I was puzzled. Indeed, I was puzzled because the aromas were significantly different. And so I knew that somehow the components in the essential oil must be different. And yet from the data that I acquired, the only significant difference was the aroma. So I had to figure out a way to be able to show that Oman and Somalia frankincense were indeed different. Different species, not just chemotypes, but different species. So I was puzzled. What can I do? I didn't see really any difference in the GCMS, in the refractive index, in the specific gravity. I knew that the aroma and when I smelled them, I knew that the aromas were different. So somehow they must be different. The components in the essential oil were somehow different, and I had to use different analytical tools to be able to identify this difference. So this lesson has been all about understanding the strengths of GCMS as well as the weaknesses. GCMS is great at being able to separate and identify the components that are in essential oils. But it has limitations. It can't separate every component, and it can't identify every component. It also can't tell the difference between natural and synthetic components. So GCMS is a great analytical tool, and it's helped me to be able to identify some slight differences in the chemotypes of essential oils found in two different regions of Oman. But when I compared the frankincense of Oman from Somalia, I couldn't see any significant difference. I had to come up with a different analytical laboratory test to be able to identify this difference.